record here. All right, so first of all, homework is not graded. Sorry, I took the weekend and I will get it graded today. My plan, Dr. Abling sent out an email and he said, make sure that you take time off this weekend. So I followed his advice and did not grade your homework. My plan is to, thank you, Daniel. My plan is to get it graded today or tomorrow before next class and take pictures of it and email it back to you. That's my plan. Small things that will make the homework easier to deal with. First of all, if at all possible, please send me PDFs. I know some of you took screen caps and those ended up being pictures. It was okay. It wasn't great. So if you could, if at all possible, either copy and paste that into a Word document or send it as a PDF or something. Pictures are just a little bit harder to deal with in terms of printing. Secondly, make sure to write a little bit darker than you're used to writing because it doesn't always come through super well in a picture. Some people's were fine. There were a couple that were really light and I had to ask for sending it back again. It's fine, it worked, it's okay. But if just be conscious of trying to write a little bit darker than you do normally. And then just, I'm printing these out and just be conscious of your organization also. If you could do just a tad neater than you do in regular, that would be great. I'll see what happens when I look more closely at them today if I have anything that is absolutely positively unreadable, but I'm hoping not. So that's the first thing. The second thing, and this depends on how far we get today, I may end up revising the schedule. So I had originally said, and correct me if I'm wrong, but I had originally said test next week Monday, correct? The next homework and then a test next week Monday. Okay, we might push that back to next week Wednesday. And actually, just one second, I'm gonna go look at my physical calendar, hang on. It's easier when I can do this in class because then I can walk away. Actually, I think I'm probably gonna do that because otherwise, that's the last day before Easter break. And otherwise we would be starting something new on Wednesday and then we would be taking Easter break off. And I have enough stuff to do that I can do it without rushing. So I'm probably going to, let's say 99% sure that I'm going to push that test and the homework back to Wednesday, April 8th, okay? Is everybody okay with that? Give me a thumbs up. People who have video, we're good. Pushing it back. Okay, I'll adjust the date on the due date for Moodle on there. Those were my housekeeping items. Anybody have any questions before we get into Primalities testing stuff today? Anything there? You could, oh yeah, you could try to type homework up if you want to. This class is probably going to lend itself more to typing up homework because it's a lot of answers. So if you wanted to, you could definitely try to type your homework up as well. You could try that. Rachel.
Homework is due the day of the test finished, so on Monday.
Nope, homework is due the day of the test. Yes. Other questions? And if I forget to, you can still submit stuff in Moodle. I think I set it up so that it does not close at the due date that I have. So if I forget to change it, you can still submit after, but I will try to remember to change it right after class. Other questions? Anything else there? Okay. Yeah, somebody just said yes. Sorry, I didn't actually try again. I didn't hear you. It's either my internet or yours. Or you can. No, we're good? Okay, all right. Let us look at PowerPoint, and I'm gonna share my screen and pop up today's PowerPoint. Okay. Today's and Wednesdays are posted online. All right, so we are doing Primality testing. Let me make this big so that I can see all of you, which is always nice. Here we go. Sorry, lots of challenges. Oops. Okay, all right, so the stuff that we're talking about next, the last stuff before the test is Primality testing. Remember that lots of cryptosystems require large primes, either in the protocol or when you're dealing with the key, right? So we've had RSA that totally, completely requires 2 large primes, absolutely. We've had Elgamal that requires a couple of large primes. We did the digital signature algorithm that requires large primes P and Q also, right? We generated P and Q a little bit differently in the digital signature algorithm, but the DSA also required large primes P and Q. So here's the question. How can you determine if an integer is prime? Is there a good way to do this? Is there a good way to determine if an integer is prime? In the 4th grade math, answer is sure, we can try to factor it, right? That is the absolutely, positively, it is going to work every single time. Why are we bothering to talk about this? We have an answer to this question. But the problem is that this is inefficient and slow. Very, very, very slow, especially when you're dealing with large numbers. Because the only surefire way to factor a large number is to try all of the prime factors, and you're going to have to go up to the square root of the number, right? Because when you think about 2 numbers being multiplied together, one will be smaller than the square root of the number, and one will be bigger than the square root of the number. So you got to go all the way up to the square root of the number. And if a number actually is prime, then none of these factors are going to work. This is dumb. This is not helpful. This is not efficient. This is not a good way to do this. And we are going to say, yeah, this isn't fast enough. So what we're going to do instead is apply a primality test. And there are 3 different primality tests that we're going to talk about over the course of the next couple of days. We're going to apply something called a primality test. Here's the problem. It doesn't work every time. That's the issue. So in other words, there might be some times when you get a wrong answer. But the good part is that it's efficient and it's fast. So these are our trade-offs. Either we can use the slow, guaranteed to be correct method, or we can use the fast, hopefully doesn't give us too many wrong answers method. Computer scientists know we want to go for fast, and we're going to say, as long as these primality tests don't give us too many wrong answers, we're going to be okay with them. So there's 3 different ones that we're talking about. The first one is Fermat's primality test, and this depends on Fermat's little theorem. So I want you to take a minute. If we were in class, I would have you turn to your neighbor, but that doesn't work so well here. Take a minute, either flip back in your notes or remind yourself from memory what Fermat's little theorem says. Go, think, please. This is one you should know. Still see people looking down, so I'm assuming that you're still hunting for it. All right, not being able to use visual cues from some of you, here we go. So if P is prime and P does not divide A, so those are hypotheses, then A raised to the P minus 1 is equal or congruent to 1 mod P. And so what we want to use for primality testing is the contrapositive. You could state the contrapositive a couple of different ways. Here's how we're going to state the contrapositive. If, and I'm switching from P to N, we're going to assume that N is the number we are trying to decide whether it's prime or composite. And since we don't know whether N is prime or composite, we want to allow for either possibility. P is usually a number that we say is prime. I'm not sure with my input, so we're going to call it N instead. So if A to the N minus 1 is not equal to 1 mod n, then one of two things is going to happen. Either n is not prime or n divides a. Remember that we have an and in our hypotheses, and we're doing the contrapositive. So when we switch or negate an and, it turns into an or, right? Remember, an and, the negation of an and turns into an or. So if a to the n minus 1 is not equal to 1 mod n, then n is not prime or n divides a. And so I don't really want to deal with the n divides a part. I just want to focus on the n is not prime. So here's how we're going to state it just a little bit differently. If a is between 1 and n, so a is going to be a smaller number than n. If a is between 1 and n, and a to the n minus 1 is not 1 mod n, that first part tells us that n is not going to divide a, right? If a is smaller than n, then n can't possibly divide a. It's not going to work. And so therefore, if I have those both, then I know that n is composite. All right, so that's the version of Fermat's little theorem that we're going to use for Fermat's primality test. If I have an a that's smaller than n, and a to the n minus 1 is not 1 mod n, then n is composite. This gives us an absolutely positively surefire way of saying that a number is composite, because we're using the contrapositive of the theorem. And when we use the contrapositive of the theorem, we know that that's always, always, always true, right? So composite is going to be an absolutely correct answer in this case. The problem comes in when we try to output prime. So here's how Fermat's primality test actually works, and then we'll look at the problems with this. So n is the integer that we're trying to decide if it's prime or composite. So we're going to let n be bigger than 1. And we're going to pick some random number a that's smaller than n. We want to make sure that a is smaller than n for the reasons discussed before, because then I don't have to worry about n dividing a. All right, we're going to go ahead and compute that a to the n minus 1, and I'm going to check if that is or is not 1 mod n. And if a to the n minus 1 is not 1 mod n, then I know that n is composite. That's the stuff on the previous slide. That's the contrapositive of Fermat's little theorem. I know I have a composite number. If I get a 1 out, then I don't know anything about n, kind of. I'm not entirely sure what happens here. And this is because now I am in the realm of the converse of Fermat's little theorem, right? The conclusion is true. If you go back to the original Fermat's little theorem on the previous slide, the conclusion of Fermat's little theorem in this case is true. That doesn't tell me anything about the hypothesis, because we don't know whether the converse is true or not. So we don't know anything about n in this case. But for this test, we're going to output prime. We might get a wrong answer. And this is where the fact that the test doesn't work every time comes in. It is possible that we might output prime for a number that is actually composite. But this is a super fast test to do, and we are going to say we are okay with that potential error. So really, primality tests should be called compositeness tests, because if you get an answer of composite out, you are guaranteed that your answer is correct. That's great, that's fantastic, that's the contrapositive of the theorem. If you get an answer of composite out, then you're good to go, no problem. If you get an answer of prime out, you may or may not have the right answer. So in other words, we might output prime when the answer is really composite. Okay, so this is Fermat's primality test in general, but it's also the overarching idea with primality tests as well. I want to run through some examples of this on parity. How are we doing? Questions? Give me a thumbs up. We're doing good. People with video, thumbs up at this point in time. Okay, All right, let's go ahead and look at Perry then and see if we can do some examples here. All right, so power mod really quick. Okay, so let's say that n is equal to that. And let's pick a random value of a. A equals, I don't know, 73. So I want to do a power mod of a raised to the n minus 1 mod n. Power mod of a raised to the n minus 1 mod n. In this case, the number that I get out is 474, 145, 338. So give me a thumbs up or a thumbs down for what you would output. Thumbs up, you would output composite. Thumbs down, you would output prime. What is your output going to be in this case? Composite or prime? What do you got? Composite or prime? Thumbs up or thumbs down? Output composite or output prime? What do we have? Help me out. Composite or prime? Don't overthink. Composite or prime? Composite, yes, we're getting thumbs up. Yes, this is not supposed to be hard, really, I promise. That is not 1, right? That is not 1 mod n. I do not get a 1, so that is going to output composite. My output in this case would be composite. Okay, let's do another thumbs up and thumbs down. Thumbs up, I am guaranteed that the answer is correct. We know for certain it is. Thumbs down, it might potentially be wrong. What do we got? Guaranteed correct or might potentially be wrong? That one's easier. Guaranteed correct. Yes. Whenever I output composite, I am guaranteed correct. Okay, let's try another one. How about n equals 1729? And I'm going to pick a random value of a. Let's go with a equals 2. So once again, I need a power mod of a to the n minus 1 mod n. Power mod of a to the n minus 1 mod n. In this case, I get 1. So thumbs up or thumbs down, what do you got? Composite or prime? Give me a thumbs up or thumbs down for output. Prime. Good. Yes. Excellent. Okay. And guaranteed to be correct or might possibly be wrong. Guaranteed to be correct or might possibly be wrong. Thank you. Might possibly be wrong. In this case, if you check, this one is actually wrong. 1729 is a composite number, but I outputted prime. That's a problem. That's not right. And so therefore, this is an example of where the test gives you an incorrect output. The test can also give you a correct output if you have prime. So let's say that n is the next prime after that number. Okay, so I know that n is prime because Perry just told me it was. We'll try a equals 2 again. And we'll do a power mod of a to the n minus 1 and n. So again, this is going to output a 1 in this case, which means you output prime. And I know that it's right because I picked a prime number, but I'm not sure whether that's actually correct or not. John, question.
If you get 1 as the output, can you try different values of a, or does it not matter what a it is?
Yes, so that's a really good question. Let's try a different value of a for, let's go back to my n equals 1729, right? We know that we have a wrong output of that one. Let's try a equals 3 and see if we still get a wrong output. So if we do a equals 3 and n equals 1729, we can do a power mod of a to the n minus 1 mod n. And I still get 1 in this case. All right, let's try a equals, I don't know, let's go up to 5 and do a power mod of a to the n minus 1 mod n, and I still get 1. So at this point, I'm becoming a little more convinced that the 1 that I'm getting out is actually the correct answer. Sadly, that's wrong in this case because 1729 is composite. I'm pretty sure it is. Let's double check. Factor n. Yes, so it factors into 7 times 13 times 19. So it's actually composite, but we can keep trying. So if we do a equals 7, you don't have to use prime numbers. I just am. Power mod of a to the n minus 1 and n. Oh, there we go. Okay, so we went up to a equals 7 and we did a to the n minus 1. At this point, we got 742. So now I know that those first 3 outputs were actually the wrong one. and I am going to really have a composite number for 1729. Make sense? Okay, so let's go back to when we had n equals 1, 2, 4, 5, 6, 1. I can try any value of a that I want to here, and I should always get a 1 out because this is going to be prime. We picked this number, we know that this number is prime. So if I try a equals, I don't know, 7, and I do a power mod a to the n minus 1 and n, I'm gonna get 1. I can repeat this for all the values of a less than n. I'm always gonna get 1. So that's one way to make this test a little bit more accurate. One way to do this is by trying a bunch of different values of a. All right, other questions on this? Okay, I'm gonna stop sharing my screen for just a sec so I can pause the video and